All right, so today we're talking about solving systems by substitution. All right, the other day on Monday we did solving by graphing. Today we'll do substitution and potentially elimination. All right, so there's this nice reference sheet for you that talks about how to solve by substitution. So in step number 1, it says to isolate our variable if it's necessary. Well, here's our example. If we have two linear equations, all right, isolating the variable means get x or y by itself. Well, if you look here, y is already isolated. So what I want to do, it says x minus 1 is substituted in for y. Okay, so I'm going to take this x minus 1 from my second equation and plug it in and substitute it in for y in my first equation. All right, so how is that going to look? We'll have 2x minus 3, where there was a y. There's now an x minus 1 equals negative 1. What do I do when there's a number attached to parentheses? I distribute. I distribute the negative 3, so it's 2x minus 3x plus 3 equals negative 1. All right, you want to combine your like terms. 2 minus 3x gives me negative 4. And I guess we're going to do 2 steps in one and subtract 3 from both sides to get negative x equals negative 4. Now, I don't want a negative x, I want a positive x. So I'm dividing both sides by negative 1. All right, so I get x equals 4. Okay, but when we solve systems of equations, we should have most times we're going to have an ordered pair as our solution. So now that we found x, we have to substitute x back in to solve for y. Okay, so here we go. Substitute x back in, so I have y equals x minus 1. Well, x is 4, so y equals 4 minus 1, so y equals 3. You want to write your solution when it applies as an ordered pair. Okay? So let's try this first one together. All right, step number 1, isolate a variable if necessary. Well, my y is already isolated here. So I'm going to substitute this 4 in for my y in my second equation. 4x plus 3. I know that y is 4 equals negative 4. Well, 4x plus 12 equals negative 4. No buckets. There we go. Minus 12 minus 12. 4x equals negative 16. Divide 4. Divide 4. X. Okay. Okay. There it is. X is negative 4. Normally I would say, all right, well now I need to plug x back in to solve for y. But at the beginning, you knew that y was actually 4. So I'm going to write my ordered pair, or my solution, as negative 4, comma 4. Wow. Let's try another one here. Okay. So practice problem number 2, neither x or y are isolated. That's why it's a little bit tougher. All right, so what I want to do is I want to pick the variable that has a coefficient of 1, of positive 1. If I look here, I have x plus y equals 2. So x and y in my first equation both have a coefficient of 1. The number in front of both of these variables is 1. Remember, if there's not a number there, I can think of it as being 1. So really it's personal preference. Do I want to substitute my y or do I want to substitute x? To stay consistent, I'm going to choose y, so I'm going to subtract x from both sides of that expression. So this expression now becomes y equals 2 minus x. Okay. So now, I'll make that all blue. Now, wherever I see a y in my second equation, I'm going to substitute 2 minus x. Buckets. So now let's solve for x. What I do when there's a number outside like this, attach the parentheses. Oh, that's right, I distribute. So 2x plus 6 minus 3x equals 3. Combine by like terms. I get negative x plus 6 equals 3. Subtract 6. Negative x equals negative 3. And then divide by negative 1. X equals 3. Well, I found x. I'm not done because I need to solve for y. Well, I know that y is 2 minus x. So y equals 2 minus x. So y equals 2 minus 3, which gives me negative 1. So my answer, 3 comma negative 1. What's up, Julia? All right, so what I want you to do, I want you to try this one, okay? Notice that neither x or y are isolated, so we have to actually isolate a variable first, okay? So I want you to pause the video here. You're going to try it, all right? And then I'm going to do it as well. Pause it. All right, so let's talk about my work here. So again, I remember I said that there was not a variable isolated, so I chose to isolate my x. So I added 4y to the other side, so I get x equals 4y plus 22. All right, remember now I want to substitute that into my other equation. So wherever I saw an x, I substituted in 4y plus 22. Distribute the 8. Okay, so 32y plus 176 minus 3y. Combine by like terms. 29y plus 176 equals 2. Subtract 176. I know these are big numbers, but it actually works out pretty nice. 29y equals negative 174. So y is negative 6. Now, when I solve for y, I got to go back and solve for x. Well, x is isolated. So I have x equals 4y plus 22. So y is negative 6. So x equals 4 times negative 6 plus 22, which is negative 24 plus 22, which is negative 2. And there's my solution. Negative 2, negative 6. All right. All right, remember this one's a little bit trickier, okay, because I have a negative x and a positive x. So what I want to do, I want to pick a variable to isolate, a variable with a positive 1 as its coefficient, which is right here. So I know that x is 6y plus 5, okay. I'm going to let's just walk you through this one. All right, so if I substitute that in to my first equation, that's negative 6y plus 5. You may be able to see something that's about to happen, but don't blurt it out. All right, so if I just remember, I can pretend like this is a negative 1 here. Distribute the negative 1, negative 6y minus 5 plus 6y equals 8. All right. Well, what happens with my y's? Negative 6y and plus 6y. Oh, these cancel out. And I have negative 5 equals 8. Is that a true statement? No. No, it's not. So if it's an untrue statement, it's no solution. Okay. What about practice problem number 5? Great question. All right, so let's isolate. Which term has a coefficient of 1? Well, if you look here, this is negative 2, it's negative 8, that's 4. Oh, that's 1. Holy buckets. So x is negative 4y minus 14. So I'm going to substitute that in for my x into my second equation. All right, distribute that negative 2. So 8y plus 28 minus 8y equals 28. Well, the 8y's cancel, and I get 28 equals 28. Is that true? Yes, that is a true statement. So it's infinite. Infinite solutions or all real numbers. All right, and that is solving by substitution. The next one will be solving by elimination. That one's pretty fun, just like all math is fun. Hope you enjoyed that. Adios.